Right, I'm going to talk about the greatest common divisor of more than two numbers. Let's take 3. And it's exactly the same, equals the largest divisor of all three of A and B and C. So for example, the greatest common divisor of, let's say, 22 and 16 and 18 equals 2, because all of these numbers are even and no larger number will do, and we can see that by rewriting 22 as 2 times 11, this one is 2 to the power 4, and this one is 2 times 3 squared. So we can see that each number is even, but no multiple of 2 will do. So 2 is the greatest common divisor. I just want to make the observation that if we think about relatively prime numbers, being pairwise relatively prime isn't enough to guarantee that the whole set is relatively prime. So I'm going to consider a nice little example here. I'm going to look at the greatest common denominator of 6, 10 and 16. I'm sorry, 15, not 16. What am I doing here? 6, 10 and 15. Now no number goes into all of those three there. You can see that's because that's 2 times 3, this one of course is 2 times 5, and this one is 3 times 5. So there's no prime factor common to all these three numbers here. However, just because the greatest common denominator of all, greatest common divisor of all those three equals 1, doesn't mean that they're not relatively prime. Because look, 6, 10 equals 2. 6, 15 of course equals 3, and 10, 15 of course equals 5. So because there's no because the greatest common divisor of all three is equal to 1 doesn't mean that they're not pairwise prime. So pairwise being pairwise relatively prime is a stronger condition than the greatest common divisor of all the numbers together equals 1. Just an interesting little fact. I'm going to stop there.